Okay, today we're starting Chapter 7, so we're on page 1 of our Chapter 7 note. Chapter 7 is exponential functions. We'll be covering the first two sections, Section 7.1, which is rules of exponents, and Section 7.2, which is exponents that are not positive. So we're going to let a and b be positive integers and x and y be real numbers. All right, so we have letters H through K. And we have the name of the rule, and on the left-hand side, and on the right-hand side, we have examples. For the most part, I'm going to do the example first, and then go to the left-hand side and write the general rule. So starting here, we have our example, a to the fourth times a to the second. Well, this is equal to a to what power? Well, when you're multiplying same bases, what's the rule for the exponents is you add the exponent. So that would be a to the 4 plus 2, which we would simply write as a to the sixth. So the general rule, when multiplying same bases, x to the a times x to the b, that is going to equal x to the a plus b. So we add the exponents. And again, hopefully you recall some of these rules, because you certainly have worked with them before. Our next example, we have 3 to the fifth divided by 3 to the fourth. This is going to equal 3 to what power? Well, the rule is when you're dividing, you subtract the exponent. So this would be 3 to the 5 minus 4, or simply 3 to the first, which is 3. So our division rule, if we have x to the a divided by x to the b, this is equal to x to the a minus b. We subtract the exponent. Our next example, a to the fourth raised to the second power. So this is when we have a power raised to a power. Well, a to the fourth to the second, you can think of a to the fourth times a to the fourth. That's one way of thinking of it. And now you're simply multiplying. So what's the rule for your exponents is you add those. So that would equal a to the eighth. To avoid doing that, when you have a power raised to a power, you multiply those exponents. So this would be a to the 4 times 2, or simply a to the eighth. So our power rule, right? When you have a power raised to a power, the rule is to multiply the exponents. So that's going to be x to the a raised to the b is x to the a times b. Our next example, we have 3abc, so we have this product, 3abc, raised to the third power. What we do here is we distribute the exponent. So this would be 3 to the third, a to the first raised to the third, which is a to the third, b to the third, and c to the third. 3 to the third, remember, is equivalent to 27. So when you have a product raised to a power, or power of a product, the rule is to distribute the exponent. So the product x times y times z raised to the power a, you're distributing the exponent, and that would leave us with x to the a times y to the a times z to the a. Our next example, 3a divided by 2 raised to the third power. So we have a quotient here raised to a power. You're going to distribute the power in both the numerator and the denominator. So this will end up being 3 to the third, a to the third, divided by 2 to the third. And we can simplify this just a little bit. 3 to the third is 27, a to the third, and 2 to the third is 8. So when we have a quotient raised to a power, again, you're going to distribute into both numerator and denominator. X to the a over y to the a. Our next example, 9,999 raised to the 0 power. Remember, anything raised to the 0 is 1. If we had 1,000,000 raised to the 0, it's 1. If we have 1/10 raised to the 0 power, it's 1. So x raised to the 0 power is 1. Our next example, we have 9,999 times x to the 0. Now the only thing that has an exponent of 0 is the x. The 9,999 is just the coefficient of x. So x to the 0 is 1, but then 1 times 9,999 is going to be 9,999. So 0 exponent with a coefficient. The only thing with the exponent of 0 is the x. So x to the 0 is 1. So this is equal to a times 1, which is a. So that simply leaves us with the coefficient value. When we have a negative exponent, all right, if I look at the example 3 to the negative 3, whenever you have a negative exponent, one way of taking care of the negative is to write it as 1 over 3 to the positive 3. And then 3 to the positive 3 is 27. So this is equivalent to 1/27. So in general, x to the negative a is going to equal 1 over x to the positive a. So to take care of a negative exponent, you write it in a denominator with a positive exponent. Staying on the rule side first and then looking at the example. A fraction raised to a negative exponent. If you start off with a fraction and it's being raised to a negative exponent, to take care of the negative exponent, just invert the fraction. So this would be y over x raised to the positive a. All right, invert the fraction. So the example, 3/4 raised to the negative 2, we invert the fraction to 4/3, and this would be raised to the positive 2. And now we can continue simplifying, distribute the 2 into both numerator and denominator, distributing the exponent 2. So we have 4 squared, which is 16, over 3 squared, which is 9. When you have a fraction with a negative exponent in the numerator, to take care of the negative exponent in the numerator, what we're going to do is we're going to take it and bring it down and place it in the denominator with a positive exponent. So this would be 1 over x to the positive a times b. Do the same with the example. We have x to the negative 3 divided by 7. Right. Take this and bring it down into the denominator. So this would be 1 over x to the positive 3 times 7, which would be more likely written as 1 over 7x to the third. We're going to write the 7 coefficient in front of the x to the third. And when we have a fraction with a negative exponent in the denominator, we want to write it with a positive exponent, so we bring it up into the numerator. So this would be b times x to the positive a. And our example, 7 divided by x to the negative 3. Bring this up into the numerator, so we can write it as 7 times x to the positive 3. Okay, so we want to remember the rules here. Now, some practice problems on the next page. It says to simplify, and to simplify means to perform all operations. So all multiplication and division. And oftentimes, think of when you're simplifying, you're thinking of using your order of operations. PEMDAS, parentheses, exponents, multiply, divide, add, subtract. Okay, now there are different approaches to this. Okay, if I work with simply the numerator first, I'm multiplying, so the rule is multiplying same bases. What do we do with the exponents? Well, we add the exponents. So this would equal y to the 7th, or a numerator. And my denominator here, all right, we have y squared raised to the 3rd, so we distribute the 3, or excuse me, rather we have a power to a power. So we multiply these powers. So this would be y to the 6th. 2 times 3 is 6. So we have y to the 7th divided by y to the 6th. Now when we're dividing, the rule is to subtract the exponents. So this would be y to the 7 minus 6, which is simply y to the 1st, or y. Number 2, we have negative and then x to the 5th, and then we have negative x raised to the 4th. Well, be careful here. All right, nothing to do right now in the numerator, so I'll just copy negative and then x to the 5th. But this negative x raised to the power of 4, that's negative x times negative x times negative x times negative x. An even number of negatives makes it positive, so this would be equivalent to positive x to the 4th. Now, these are same bases, right? Same bases of x. We're dividing. X to the 5th divided by x to the 4th would leave us with x to the 1st, because we subtract the exponents and just carry over that negative sign. So this is equal to negative x. Number 3, all right, we have a product raised to a power here. We'll distribute that power. So we have x to the 5th, y to the 5th, divided by x, y to the 3rd. Now from here, x to the 5th divided by x to the 1st, we subtract the exponents. That will leave us with x to the 4th. Y to the 5th divided by y to the 3rd, subtract the exponents. 5 minus 3 is 2, y to the 2nd. So that's x to the 4th, y to the 2nd. Number 4, we have x squared y, so we have this product raised to the power k. So we distribute the power k, so we have x squared raised to the power of k, and then y to the 1st raised to the power of k. And a power to a power you multiply, so this would be equal to x to the 2 times k, or 2k, and y to the 1 times k, or simply k. So we have x to the 2k, y to the k. Next, number 5. we have 1/2 x squared raised to negative 3. Well, this x squared, all right, you can think of it as x squared over 1. So if we want, we can actually write this as the fraction x squared over 2 raised to the negative 3. Now, if I want to take care of the negative exponent, I would invert our fraction. So we would have 2 over x squared raised to the positive 3. And now distribute our power of 3 into both the numerator and denominator. So we have 2 raised to the third, and then x squared raised to the third. Power to a power you're going to multiply, so that will give us x to the 6th. 2 to the third is 8, so we have 8 over x to the 6th. Number 6, we have 2 to the x times 2 to the 4th. Same bases. Copy the base 2. And when we're multiplying same bases, the rule is, what do you do with the exponent? You add those exponents. So this would be 2 to the x plus 4. And that's all you can do with that. Now, number 7. Number 7, we have x to the negative 1 times y for a numerator, and then xy to the negative 2 in a denominator. Okay, so there's more than one approach to this. What I'm going to do is I'm going to take the x to the negative 1 in the numerator, and I'm going to bring it down, so I'll have a x to the positive 1 in the denominator, and the y to the negative 2 in the denominator. Push that up, so I'll have a y to the positive 2 in the numerator. Okay, so what's happened is this y here has stayed. The y to the negative 2 in the denominator has moved up to be a y to the positive 2 in the numerator. The x in the denominator has stayed, and the x to the negative 1 in the numerator has pushed down into the denominator to be an x to the positive 1. And what we have here, y to the first times y to the second is y to the third. And x to the first times x to the first is x to the second. So we have y to the third over x squared. Number 8, I look at this and I can take this y to the negative 1 and move it up to the numerator. So we have 2x squared. This is going to be y, and then times another y to the positive 1 over 6x. Now we can reduce, right? The 2 and the 6 can reduce. 2 divided by 2 is 1. 2 divided by 6 is, 6 divided by 2 is 3. And then the x squared and the x can reduce. Okay, so we have x times y, which is x times y squared for a numerator, and 3 as a denominator. And that's simplified. Number 9. All right, let's see. Inside parentheses, I think I'm going to leave this as is and not do any moving of these negative exponents. All right, so we're multiplying these. So let's multiply the coefficients, meaning we'll multiply 4 times 4. Let me write this out. And then I'll have x squared times x, and then y to the negative 4 times y to the negative 3. 4 times 4 is 16. X squared times x to the first is x to the third. Y to the negative 4 times y to the negative 3 is y to the negative 7. And that's simplified. If we didn't want the negative exponent, if we wanted to use only positive exponents, then we would simply place the y to the 7th in the denominator and have 16 x to the 3rd over y to the 7th. Now, number 10, it's getting more complicated. More than one approach to this. You could take care of the negative outside the parentheses by inverting the fraction. I think what I'm going to do is I'm going to look inside the parentheses and see about simplifying this first. All right. I'll move some things around, meaning I'll move this up into the numerator, and the z to the -1 will go down into the denominator. So let's see, I'll have 4 x to the 4th times another x is going to be x to the 5th. Y squared is going to stay, and now that z to -1 is going down in the denominator. I still have the 2, the y to the 7th, and the z has come down. And this is still all being raised to -3. Okay, next, I'll simplify what's in here, right? 2 goes into 4 twice, 2 into 2 once. Now, the x to the 5th, oh, that doesn't divide out with anything. But the y squared and y to the 7th, right? Y squared and y to the 7th will leave me with a y to the 5th in the denominator. Okay, so let's see, what do I have? 2 x to the 5th for a numerator over y to the 5th z for a denominator. And raising this to the -3. I'll invert the fraction. So we have y to the 5th z over 2x to the 5th to the +3, and we still have to distribute the 3. So we have a final answer of y to the 15th z to the 3rd over 2 to the 3rd is 8 x to the 15th. Okay, I'm going to ask you to try number 11, and we'll go over that in class. All right, so try number 11. This concludes our lesson for tonight.